Hey guys, so this video is not going to be very good quality because I have my iPhone taped to a folder and I'm recording this from home. So take a look at the top. These notes should be relatively quick. Remember, for inverse functions, which we've been covering the last couple of days, remember that your domain and range are swapped, okay, or they're reversed. So what that means is that the domain of x is the range of the inverse and vice versa. Okay, so if your original point f of x is a point xy, then on f inverse of x, the point would be yx. They're backwards from each other. Also remember that their slopes are reciprocals. Okay? So all of the long problems that we've been doing in class typically are not how the AP test covers this topic. Usually they will ask you questions more like what you see in this packet. So take a look at the first one. It says that h of x equals f inverse of x. So what that means is that h and f are inverses. So h is f's inverse, f is h's inverse. So typically what I do with these is I'm going to make a little table here. I'm going to put the one that's in the chart on the left side and then the other function on the right side. Okay, now remember, h of x is the same as f inverse of x. So from here, I'm going to say, okay, well, I want to write an equation that's tangent to h at x equals 5. Okay, well, then it's 5 comma something for h. Also, I'm going to need a slope, right? That's how you write the equation of a tangent line. Okay, but if h of x point is 5 comma something, then f's point has to be something comma 5. Because remember that these guys are always backwards from each other. So then from there, I'm going to look in my f table and I'm going to look for 5, but I'm not going to look for it in the x column. For f, remember that 5 is actually the y value. So if I come down my f column here, I notice that 5 happens here at 5 as my y or f value and then 2 as my x. Now, remember the relationship between the slopes is that this one and this one are reciprocal. So I need to know the slope at 2. Okay, well then I'm going to look at f prime. I'm going to come down to 2, which is right here. And I can see that f prime of 2 is 3. Now remember that if the derivative for my original function is 3, the derivative for my inverse function is the reciprocal of that, which would have been a third. Also remember that if my ordered pair is 2, 5, then my inverse function's ordered pair is 5, 2. And then from there, if I want to write the equation, the tangent line, I would do y minus 2. 1/3 is my slope, x minus 5. So although my graph was not in my, even though I did not actually have my h of x function in my chart, I can still answer all those questions about it. Okay? So take a look at letter B. This time it tells me that G and J are inverses. Okay, so these guys are inverses. I'm going to set up my chart. I look up in my table. I notice that G is in it, but J is not. Now remember, what's the relationship between these two guys? They are inverses. So from here, I want to write the equation, the tangent line to J at 0. Well, then 0 must be J's x value. And remember that for J and G, they're inverses of each other. So if 0 is the x value here, then it has to be the y value for G. Then I'm going to look in my G column, not for the x to be 0. That's not what I want. I want 0 to be in the G of x column, so I'm looking right here. So at 0, my x value is 3. Now, if my point here is 3, 0, then my point here needs to be 0, 3. Then from there, remember, I'm going to find my two slopes, and I remember the relationship between them is a reciprocal. So my slope on this side is going to be G prime of 3. Look up at your chart. Here's 3, G. Now I want G prime, so that'd be a half. And if my slope here is a half, then my slope for the function I want, which is the inverse function, is 2. Because remember, these guys always come out to be reciprocals. We've proved that now a bunch of times. Okay, then remember, I want to be on the tangent line for j, so I'm going to use these two pieces of info. So it's y minus 3, 2 is my slope, x minus 0. Okay? All right, next one says q of x equals f inverse. Okay, that tells me that q and f are now inverses. Oops, and actually I did that backwards. Remember, on the left, usually I'll put the one that's in the chart. So since q is not in the chart, I'm going to put f on that side. I'm going to put q on the right side. That's really not a right or wrong thing, more just a preference thing. Okay, so look here. I want q prime at 2. Well, then 2 is the x value for function q. That means that it must be the y value for function f. Then I'm going to come here into my chart. I'm going to look at 2. Okay, 2 is in the f column here. And so since 2 is here in the f column, I look back at my x is a 0. Now remember, if f is 0, 2, then q is 2, 0. Okay, then from there, I want the slope. Well, then I need to find f prime of 0. Then I'll take the reciprocal of that to know the slope for g. So f prime of 0 here, I notice it's a -1. And then remember that when I reciprocal -1, I'm just going to still get -1. Now, this one did not ask me to write the entire equation, the tangent line. It only asked me for q prime at 2. So my answer would only be from right there. But if they wanted the equation, the whole tangent line, obviously you could do it. Okay? All right, next one. It tells me that p and g are inverses. So look up at your chart. I know g of x is in my chart. P of x is not. Remember, what's the relationship between the two? They are inverses. So if I want p prime of 3, that means that 3 is the x value for p. But that tells me that 3 must be the y value for g of x. So then I'm going to come up here to my chart, and I'm going to look for 3 in the y column in the g of x. So g of x is here. I'm looking for 3. C3 is right here. 3 happens at x equals 2. So 2, 3 is the ordered pair for g. Now, while I'm at 2, I'm going to go ahead and pull g prime. So when x is 2, g is 3, g prime is a third. That's my slope. Okay, well then once I know all that info, I can fill out the other side. 2, 3 reverse, p of x point is 3, 2. And if my slope here is a third, then my slope here is 3. So that means that p prime of 3 is 3. Okay? Hopefully that makes sense. Next one, letter E, it says, does g of x have a root on the interval from 0 to 2? Okay, well, let's just think about that for a second. Okay, a root means a 0. And so if I were to look at my y values in the chart here, okay, at 0, hopefully you can see g of 0 is -0.5. Okay, and then at 2, my y value is 3. So think about, if my graph goes from -0.5 until 3, did it have to hit 0 in between? Hopefully you know the answer to that is yes. So the theorem that guarantees that is IVT. So I'm going to put yes. IVT guarantees this. Because, and then remember, there are 3 statements that I have to make. We're going to skip this last part just for the sake of room here. So step number 1, okay, your function g of x has to be continuous. Now, on the AP test, they do a very good job of writing this into the question. Technically, this equation, this worksheet that I made doesn't say, but we're just going to assume that it's continuous on 0 to 2. Okay, so step 1, I make sure it's continuous. We're going to pretend like check it is. Step number 2, we need to find g of 0 and g of 2. So I'm going to use my chart for that. G of 0, look up at your little chart thingy. 0's here. G is -1/2. Then I want G of 2. Remember, we said that G of 2 is 3. And so I check it's continuous, then I check my Y values. Well, then after I do that, I make sure the Y value that I want is in between those. So it is continuous. I have my Y values, they're not equal. Then the third one would be that 0 has to be in the middle. 0 is between -1/2 and 3. And so since that is true, check, check, check. That means IVT guarantees this. Okay? All right, so flip over to the back side, just a couple more left, and then we are finished. Okay, flipping over here to the back side, pause it if you need to. Okay, up here we are taking a look at number 2. It says f of 2 is -3, f prime of 2 is 3/4. Then it tells you here that if g of x is f to the -1, that means that g of x and f of x are each other's inverses. Okay, remember, that's what that means. So if they are each other's inverses, then remember that what that means is that their ordered pairs are backwards. Okay, and then it also means that their slopes are reciprocals. So what I'm going to do is, since I have information about f, I'm going to put that on the left side. And then on the right, I'm going to put all my info about g of x. Now, for my f of x stuff, look what it tells me. F of 2 is -3. Well, then 2 -3 is the ordered pair. And then it tells me that f prime of 2 is 3/4. So that's the slope on this side. Okay, well, now think about, if my slope here is 3/4, well, then my point here is going to be -3, 2. And then my slope here is going to be 4/3. Okay, and so all those proofs that we've been doing, hopefully that's drilled it into your head, this relationship. My points are backwards, my slopes are inverse or reciprocals. Then from there it says, what is the equation of the tangent line at -3 for function g? Well, I have my point right here, I have my slope right here, then I'm ready to write it out. So it'd be y minus 2, 4/3 is my slope, x plus 3. Okay. All right, go down to the next one. We learned this on Monday. Remember that for even functions, f of a and f of -a have the same sign. But for odd functions, they have opposite signs. So if it's an even function, then your y values are going to stay the same. If it's an odd function, then your change in x values is going to change your y value as well. Okay, last thing, remember that the derivative of an even function is odd, and the derivative of an odd function is even. So take a look at your next example. It says f and g are differentiable functions such that f of 4 is 6 and f prime of 4 is 3. Then it says g of 4 is 8, g prime of 4 is -3. Okay, part A says, given that f is odd, find f of -4 and f prime of -4. Okay, so I'm going to put here, I know that f of x is odd. And I was given that f of 4 is 6. Okay, well then think about it. If f is odd, then f of 4 is 6. Then f of -4 needs to be -6. Because remember, for odd functions, when you change the sign on x, you have to change the sign on y. Okay, now the other thing that we know is that if f is odd, then f prime of x must be even, right? Because the derivative of an odd function always switches to be even. So let's come up here. I'm given that f prime of 4 is 3. Well, if f prime of 4 is 3 and f prime is even, then when I change my middle number to be a -4, think about, should my 3 change to a -3? Well, the answer is no. If this one's a 3 and it's even, then if I change it to a -4, it should stay +3. So my answers would be that f of -4 is 6, f prime of -4 is 3. Okay, next one right next to it, letter B. Tells me that g of x is even. Okay, it tells me g of x is even, then it tells me that g of 4 is 8. Okay, that's given right here in the question. So if g of 4 is 8 and g is even, then I need to find g of -4 using my properties. So remember, look up here at the top. Whenever my function is even, f of a and f of -a should have the same sign. So if g of 4 is 8, then g of -4 should also be 8. Then I want to know about g prime. Well, if g is even, then g prime must be odd. And if g prime is odd, they told me that g prime of 4 is -3. Well, then I can use that to determine what g of -4 would be for the derivative. Now remember, now g prime is odd. So if my first derivative here is -3, and I change the 4 to a -4, that's resulting in that being a +3. So those would be your two missing values. Okay? Okay, from here, letter C says, given that h of x equals f of x over g of x, find h prime of 4. Okay, so notice h of x equals, it says, f of x over g of x, and then they're asking you to find h prime of x. Okay, well, the first thing that you should notice is that that is going to need, oops, you can't even see that. That is going to need quotient rule. Okay, so if h is f over g and I need to find h prime, then I need to do a little mini quotient rule. So let's split it up. My high is going to be f of x. My ho is going to be g of x. And then from there, I'm going to take the derivatives. So d high is going to be f prime of x. And d ho over here is going to be g prime of x. Now, if you're wondering why we're not doing chain rule, it's because when the middle is an x, the derivative of that core is just like a times 1. So that's why we don't really have to put it. Okay, so ready? Let's do our quotient rule. So if my original function is called h of x, my derivative function is going to be called h prime of x. And then remember, it's going to be ho d high. So that's going to be g of x f prime of x minus high d ho. Okay, we'll look back at your quotient rule. High is f of x, d ho is g prime of x. So that's going to be f of x, g prime of x. Okay, and then over, I want ho squared on the bottom. Remember that my ho over here was g of x, regular. So g of x squared. Now remember, that's h prime of x. I want h prime of -4. So h prime of -4 equals. And then I'm going to come back to these values that I found here, 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 and here. And I'm going to plug all this stuff in. So first I want g of -4. Well, g of -4 is 8. Then I want f prime of -4. Well, f prime of -4 is 3 minus. Next, I want f of x of -4. Well, f of x was -6. And then g prime at -4 came out to be 3. So on the top there, I have 8 times 3 is 24. Minus a negative, that's really a plus 18. Okay, then on the bottom, I need to have my ho squared. Well, remember, my ho is just a regular g of x, and regular g of x is here. That comes out to be 8. So really, that's an 8 squared on the bottom, which is a 64. Now, from there, if you want to add up more stuff, you totally can. I'm just going to leave it like that. Since it's a free response question, I don't have to work that down into like an easy, nice decimal. Okay. All right, last 3 left. Take a look at letter D. Okay, I want to take the derivative d dx of e to the f of x. Okay, well then remember, I need to keep e to the f of x the same. And then I need to multiply by the derivative of f of x. Okay, well think about the derivative of f is f prime of x. And then the derivative of the core inside of that is just an x, so the derivative of that is a times 1. Then I want it when at 4. So when I want it at 4, this is going to be e to the f of 4 times f prime of 4 times 1. And then from here, I'm going to come back up here to all this information they gave me and plug in my numbers. So first I want f of 4. We'll come back up here to the top. Okay, right here, what was f of 4? F of 4 was given to be 6. Also note f prime of 4 here was 3. So my answer is going to be e to the 6 times 3 times 1. Well, that's really just 3e to the 6. That would be your answer. Okay. All right, next one. We have, I'm going to skip e, come to f. So I have 2x squared times g of x. Okay, well, hopefully you know that's going to need one of your specific rules. It's going to need a product rule. So my u is going to be a 2x squared. My v is going to be a g of x. Well, then my u prime is going to be a 2 times 2 is 4x. And my v prime is going to be a g prime of x. Then remember from there, it's one diagonal plus the other for product rule. So my derivative is going to be 2x squared g prime of x plus 4x regular g of x. Then I'm plugging in my 4. So I want 2 times 4 squared g prime of 4 plus 4 times 4 regular g of 4. And then from there, I'm going to come back up to my givens in my equation. I'm going to plug in all the numbers that I have. So 4 squared here is 16. 16 times 2 is 32. And then for my g prime of 4, I'm going to consult what I was given. So look up here. Remember that g prime of 4 was given to be -3. G prime of 4 was given to be -3. So that's 32 times -3 plus. Okay, then 4 times 4 here is a 16. And then g of 4, I'm going to go back to my table. It says here that g of 4 is 8. So I'm going to replace my g of 4 here with an 8. And then from there, I don't even feel like working that down, so I'm just going to leave it. Okay, but remember, it's a free response. I don't have a multiple choice question I'm trying to answer or anything like that. So that's good enough if it's going to be an F or Q. Okay? Good job. Now, the last one that's there in the middle, I don't really have a ton of space to do it, but what I want to point out to you about that middle one is that this actually has more than a single chain rule in it. So remember that whenever they tuck that exponent in, it looks like it's a cubic. That is the same as f of 4x cubed. So when I take the derivative of that, my 3 is going to multiply down to the front. And then my f of 4x is going to come out. So my 3 comes down. Now it's going to be squared. Then I'm going to multiply by the derivative of the middle. Now, the derivative of the middle doesn't include the squared on it. It's just the middle part. So the derivative of f is f prime of 4x. And then the middle of that is a 4x. And if I take the derivative one more time, I get an extra times 4. Now, remember, anytime you get multiple constants and they're multiplied, you can just go ahead and do it. So my 3 times my 4 here, that's really a 12. F squared of 4x times f prime of 4x. Okay, and then from there, I'm good enough with that. You can just leave it. But if you were to plug in, just keep in mind, when I plug in 1, I'm plugging in 1 to the middle. So that would actually still be a 4. That would still be a 4. So I'd have 12 times f of 4 squared, whatever that is, and then multiplied by f prime of 4. And hopefully you understand why that is. It's because you're plugging in 1, but you're plugging it into a 4x. So 4 times 1 leaves that as a 4. Okay? All right. So hopefully you got it. You are moving on to your homework on tables.